Hello, good evening. Good evening, everyone. Welcome to 111th video on misconceptions in physics. This is Ratankar Rao, teaching physics in an international school in Bangalore. And well, it is my hobby of doing videos on misconceptions which are related to the problems which the students feel it difficult to solve. And I try to solve these problems. And this is my introduction. So all the videos that has been done so far, you can observe it or you can view it if you become a member of my YouTube channel, or maybe if you want to see it line by line, then maybe you can visit my website, which is already given over here. Oh my God, I am blocking this. Right, it's ratankar.com. Okay, let me begin with today's series. And as you all know, so recently I had been getting mails on one of the typical type of problems, which is on comparison problems. And I have seen that many students make a mistake. These examinations are coming forward. So I thought these problems would be interesting. These problems are not related to one particular chapter or one particular concept. It could be from any chapter, any concept. Okay, so you cannot expect this, that it should go in order, but as much as possible, I will try to put it in order. So you can see such problems in electricity, magnetism, mechanics, okay, thermal physics, wherever it is, in every branch of physics. I have observed that in any kind of competitive exams, you at least get 2 questions. Okay, if it is for a 20-mark paper, definitely 2 questions. And if it is for a 100-mark paper, you can see at least something like 5 to 6 questions coming from this concept. When you say concept, it's something like you have one concept and you have a formula corresponding to it, and you are now going to, and 2 different values would be given, and you need to compare and finally get a value for one of the observable. Anyway, while we start doing it, you will come to know about it. Now, here, the concept is clear, but the only thing is the values are not given. Okay, only based on logical reasoning, you need to observe. So in yesterday's video, I hope you have liked this video. Yesterday's video in MCP1, we had compared the distance between 2 balls when they are being dropped one after the other, and we did this example. And then I got 2 or 3 questions related to it. Is it that that the distances, if I consider only distances, okay, do I get this result, or can I do the same example even for velocities and accelerations? Okay, now this was an interesting question, so I thought let me take it out. This is not, okay, there's no student response here because it's not asked as a question, or maybe I did not ask this question in my class or in my tutorials, and as a result of it, this was a new question. I thought maybe in the future examinations, I might ask you if you are one of my students observing my lectures. Okay, so now, so we need to find out the relative velocity and relative acceleration. Once again, same problem, 2 balls of different masses. 2 balls of different masses. One ball and second ball of different masses are being dropped one after the other. So you can see that there is a distance between them. Okay, and we have seen that this distance will keep on varying with respect to time. Okay, now the question is not that, not the distance, the relative velocity. Relative velocity, what is relative velocity? You already know relative velocity. You have learned in your mechanics chapters. Relative velocity is nothing but velocity of this particle with respect to this particle. You can either say, let me say this is A, this is B. You can say velocity of B with respect to A. With respect to A. You can say like this, or velocity of A with respect to B. Any one of them is right. Okay, so he is asking you to find out what is relative velocity and relative acceleration. Similarly, B is moving with some acceleration, A is moving with some acceleration. Now, what is the relative acceleration between them? So this is the question we asked. Okay, both of them I have put it together. So now we need to find out this. Now, how do we find out? Now, once again, as I told you, any logical question that is being asked, the first thing that you should realize is that it could be a logical question, but you should somehow put some numbers there. Okay, you can assume, and then you have to put some numbers. Only then it will be helpful for you. Otherwise, you will not going to get the answer. Okay, physics or solving problems in physics is not fact-based. Remember this, it is not fact-based, it is not guess-based. It is mathematically, you need to bring some mathematics. You need to use it to solve your questions. Okay, now let me begin. So therefore, now what we do is, let us assume that the ball B has taken a time t to reach this position, to reach the position B. Okay. So therefore, the velocity of the ball or the speed of the ball at this point is given by Vb is equal to u plus at. U plus at. So what is that value? U. What is u? I said it has been dropped, which means what? It is 0. Plus, what is a? A is nothing but, okay, it's the acceleration due to gravity. What is the value? G. Which G? Positive or negative? I said that anything that you take upwards is positive and anything that you take downward is negative. Negative over here. So therefore, this should be minus G. What about time? Is time negative? No, time is not negative. Time is positive. So time t. Okay, so thus I will write this as a Vb vector, right? Vb vector is equal to minus G into t, which means you are getting a velocity equal to negative. What does it mean? That means the velocity vector is in this direction. Observed, and it is correct also, because until unless velocity vector is not in this direction, you cannot expect the particle to move down. It is moving correctly, right? Okay, nothing wrong. Okay, you can always get negative answers. Negative marking is not possible. Okay, should not get negative marking, but negative answers in physics are good. Okay, now we are describing a vector, so negative vector is possible. Now Vb equal to minus dt. Now let us understand the same thing for this. Now after a time 1 second, I said you assume, right? After 1 second, you have dropped this ball, which means in a time t minus 1 seconds, the particle, the ball would have reached some point over here in a time t minus 1 second. Okay, so at this point, let me call this as some C over here. Let me call this point C here, VC, because I have taken A already here. VC, once again, I'll use the same formula, U plus AT. Now, what do I get here? Sorry, not T, this should be T minus 1, because after 1 second only, I have dropped the second ball, right? T minus 1. So in this case, U becomes 0, then this becomes minus G into T minus 1. We have got VC here. Now, what is being asked? VBA is being asked, or VBC. Here I should have written VBC over here. VBC. Now, what is VBC? VB comma C is nothing but VB minus VC. That's what we can write. Okay, what is the velocity? What did we do earlier also? We took what was this distance y2, then y1, then we subtracted y2 minus y1. Okay, in MPC1. Okay, if you look at this, we have done the same experiment. Okay, only thing is the difference there is we have looked at the distances, not the velocities. So towards it, let us apply these values. Now, what is VB? VB is minus GT. Let me apply minus GT minus G into T minus 1. Okay, and this should now be equal to minus GT minus of minus GT plus G. This is what I get. And this should now be, okay, I'll write here itself. Minus GT, minus into minus becomes plus, plus GT, minus into plus becomes minus, minus GT, minus G. So this goes away. And what do you get now? VB minus VC, the relative velocity between B and C. Okay, what is the velocity of this with respect to this? Is equal to minus G. Is it dependent on time? No, it's not dependent on time. It is a same constant. What do you understand by this? It means that, okay, you are moving in a car. Okay, horizontal motion, not vertical. You are moving in a car at 30 km per hour. After some time, your friend moved in a car which is moving backwards. Now, both of them are experiencing the same sort of acceleration, which means what? Okay, now you are going at 30 km per hour. After 1 second, your velocity is increasing by 1 km per hour, let us assume, which means you become 31. Now, when your friend started, maybe he started at 0 km per hour. Okay, now 0 became 1 over here because he is also experiencing the same acceleration. So 0 became 1 km per hour. Now, when you made 32, your friend started doing 2 km per hour. Right? When you made 33, then he started moving at 3 km per hour. Now, what is the difference between these two? Difference between them is 33 minus 3, which is 30 once again. 32 minus 2, 30. 31 minus 1, 30. See, every time you see that the difference in velocities are same. Okay, velocity, individual velocities are increasing, but difference in velocities is always seen to be a constant. So, which means, which is the right answer? This is the right answer. Okay, so whatever happens to distance, the same thing happens for velocity is incorrect. Okay, it can change. Now, if you ask me what happens in case of acceleration, I don't want to take a separate video for this. Let me discuss it here itself. Let me do it for acceleration. Now, for acceleration, what happens? See, this particle B is experiencing an acceleration equal to G, minus G, minus G. What is this particle experiencing? This is also experiencing a minus G only. So, the difference in acceleration would be 0, right? So, therefore, it is equal to 0. I have not put the option here. Okay, so the option E here would be 0. Okay, it should not be constant. Okay, if there's no option, then you can put remains constant. But usually we'll give this an option and we say the relative velocity is seen to be constant, the relative distance is seen to be increasing with time, the relative acceleration becomes 0. I hope you understood a detailed view of how to calculate the relative velocities, or how does, in case of relative velocities, how things changes, and as a result of it, how to answer these kinds of questions. Many places, many papers have seen such kinds of questions. Students make a lot of mistakes. The reason is because such kinds of questions not only involve only mathematical substitution, but it also involves some logical reasoning. Until and unless you do not understand this logical reasoning, becomes very difficult. Okay. Thank you, friends, for watching this video until the end. And if you really love these such kinds of videos, do write back to me, share this with your friends so that I get more number of views and it reaches to far and near around the corners. And comment on the video and subscribe to my channel for more updates. Thank you.